Now I'm going to explain why you needed to know that information about 30, 60, 90s and 45, 45, 90 triangles. Example, or I guess problem number 3 in your lesson says to find the area of an equilateral triangle that has a 6-inch radius. Okay, so we need to know the parts of the triangles. So if I were to draw just a regular equilateral triangle, let's use your imagination. All these sides are equal because I drew them that way. All right, so if it's telling me it has a 6-inch radius, there's a radius, okay? Then some of your other questions talking about an apothem. Well, that is your apothem, okay? So this is the radius of a polygon. It's going to go from the center of whatever the polygon is. It could be a rectangle, it could be a pentagon, whatever. Okay, from the center to the vertex. And then an apothem, that's right here. Your apothem is going to go from the center. It's going to go straight down to the base. Now, why is this straight important? Well, if you go back to the straightest of straight lines is what? A perpendicular, right? So our apothem is always going to create a right angle. This should now start to look pretty familiar to you. Okay? Now, the fact that this is an equilateral triangle in the problem is very important because apothems in equilateral triangles are not only straight, which means form 90-degree angles, but they actually bisect the base. Okay? Of course, bisect means it's going to cut it into 2 equal halves. That's very important. It's going to allow us to eventually find the missing piece, which is half of the whole, and then we have a side of the triangle, which is what you were looking for. All right, so let's do an example. Your lesson says to use 6. I'm going to let you use 6 inches all on your own, so I'll make mine up with a 4-inch radius. Okay, so if it says find the area of an equilateral triangle with a 4-inch radius. Okay, well, I'm really big on drawing pictures, so I'm going to go ahead and draw myself this little curvy edge triangle. Just imagine. And I'm going to draw myself a radius. I know it's going to be 4 inches. And that's all the information they give me. But I know that usually when a radius is involved, there should always be an apothem. I don't know it, so I'm just going to call it A. I also know that apothem is straight, therefore it forms a 90-degree angle. And since this is an equilateral triangle, I now know that this base has been cut into 2 equal halves. Now, do I know what this half is? No. So I'm going to call it X. But if I could eventually find X, then I could take this X, this one's also going to be X, and eventually I can find my entire side, right? Okay, so then the question becomes, well, what in the world do I do with this? How in the world can I possibly find what the A or the X is? Well, it's one more thing that we need to know about equilateral triangles and how special they are. Apothems and radii, when drawn in equilateral triangles, form 30, 60, 90 triangles. So this little guy in here is a 30, 60, 90 triangle, with the 30 being the small angle right over here by the vertex, and the 60 being right up here between the radius and apothem. Okay, so now I know from the last video that I can use what numbers? 1, 2, square root 3 in order to use proportions to find the missing pieces. Okay, now this is for my overall problem, so I'm just going to drop right over here and draw a new picture so I can make this a little bit bigger. So this miniature triangle in here looks like this. This is an A, this is the X, this is the 4, and this is the little one, so this is the 30, and this is the 60. Okay? Now then, I'm going to draw my normal 30, 60, 90 triangle, which has, of course, the numbers 1, 2, square root 3. So there's my 90. Across from it's the biggest number, which is 2. There's my 30. Across from it's the smallest number, which is 1. And there's my 60. Across from it is the only one left, right? 1, 2, square root 3. So now I have my 2 triangles, okay? And I have to know how to set up the proportion in order to find the missing sides, okay? So I'm going to go ahead, set up my proportion. And here I'm just going to go this triangle to this triangle.